Hey everyone, and welcome back. In this short lecture, we'll have a look at universal functions along with a few other array manipulations available inside of NumPy. As usual, we'll need to start by importing NumPy, and then I'll go ahead and create two different arrays. One from 0 to 19, and then the other from 0 to 38, but we'll have it going up in jumps of 2. And then I'll also reshape both of these arrays to have 2 rows and 10 columns, so they're a matrix as opposed to a vector. The first method we'll look at is transpose, which does the same job as transpose did inside of Excel. And just to quickly recap here, transpose basically rearranges the elements or dimensions inside of our array. So our rows would become our columns and vice versa. And let's now use transpose on array 1. Currently, array 1 has 2 rows and 10 columns. If we call transpose on this, which we can do by saying array1.t, and then the t here has to be a capital, we can see that our rows and columns have been flipped. So we now have 10 rows and 2 columns. Next up, we'll have a look at universal functions, commonly abbreviated or referred to simply as ufuncs. And these are short functions that operate on our NumPy arrays on an element by element basis. So they are another example of element-wise operations that we looked at early on in this section. There are numerous universal functions available inside of the NumPy library, but we'll have a look at some of the most common and most useful of these here. We'll start with the square root universal function, which we can just use to return the square root of every element inside of an array. We can call it by saying np.sqrt, which is sqrt, and then inside of our parameters, we can pass in the array that we want to perform this function on. And I'll pass in array 1. And this will then return the square root for each element inside of this array. So we can see that for 1, we get our square root of 1, 4 returns 2, 9 returns 3, and then 16 returns 4. So just the square root of each element. And of course, there's all the other numbers in between here too. We then have options like add, subtract, multiply, or divide. So we could say np.add and then pass in our 2 arrays. But these particular universal functions aren't too helpful, as we could of course just say array 1 plus array 2, like we looked at previously. There are also options like log and round, as well as some trigonometric functions like sine and cosine. These functions aren't too common for data analysis tasks, so we won't have a look at them in detail here, but to use them, all we'd have to say is just np dot and then the name of the function, so sine or round for instance. Finally, we'll take a look at the maximum and minimum functions, which perform element-wise comparisons between 2 arrays and will then return either the maximum or minimum value of the 2 arrays respectively. To demonstrate this, let's try them out on our 2 arrays here. So we'll call np.maximum and then pass in array 1 and array 2. And then if we have a look at the output of this, we'll see that it's returned the largest number from each position of our arrays. And then we can do the same with minimum, but this of course will return the smallest number instead. Okay, and that wraps up our lecture on some of the universal functions and other array manipulations inside of NumPy. You probably won't need to use these too regularly, which is why it's a short lecture, but it's still helpful to be aware of them and know what they do. And then in the next lecture, we'll go through and have a look at the practice activities here for our section on NumPy.